Alright, sorry about that. The batteries seem to have died on the last recording. So now that we've got fresh batteries, we'll just pick up where we left off. This is 7.1 section 2's homework still, and then I'll just go straight into 7.3 after that. So we left off at 12, and basically we saw that the fill-in we would need on line 4 would be not M, and that would give us the answer of G from 2 and 3 through a disjunctive syllogism. Now 14, we've got if not R, then D, not J, then not R, in or not R, line 4. And the conclusion we want is not F, or, if not F, then not R. So once again, this is going to be a hypothetical syllogism, because the conclusion is a conditional. So if square, then circle. If circle, then triangle. Therefore, if square, then triangle. The conclusion we want to reach is not F, then not R. So not F is the square, not R is the triangle. So we simply look at what's here, and we see that line 2 has not J, then not R. So we're not going to use 1. We're not going to use 3, we're going to use line 2. So not J, then not R. So we know the circle is not J. So what we would need then, since we have this one already, is this line, which is not F, then not J. So lines 2 and 4, hypothetical syllogism, would give us our answer. 16, we've got if J, then E, B or not J, not Z, then J, line 4, and then the conclusion we want is J. Well, that one's real easy. You can see right here on line 3, you've got if not Z, then J. So if not Z is the square and J is the circle, what we need is the square, which is not Z. Right? And then 3 and 4 give us our answer through modus ponens. With number 18, we've got if S, then M, then G, if S, then M, N, G, G, then R, then not S, and we want to get to not S. So again, with the negation there, we're looking at a modus tollens. So modus tollens, if square, then circle, not circle, therefore not square. So not S. So the square is S. So what we need is a conditional where the S is the antecedent, and we have that here at line 2. So we're not going to use 1, not going to use 3. So it's if S, then M and G. So the circle is M and G. So we know we have to fill in here M and G. Okay. So line 4, what we're going to need is not M and G. And then lines 2 and 4 through a modus tollens would give us our answer. And finally 20, we've got H and A or T, not S then P or P then T, N or T then P, line 4 and then T. So we want to end up with T by itself. Again, this one very simple. Right here on line 1 you can see H and A or T. We want to get to T, so all we have to do is to deny the H and A like that, and then lines 1 and 4 through a disjunctive syllogism give us our answer. Alright, so that is what we're looking at in terms of 7.1 section 2. So now we'll just go ahead and jump into 7.1 section 3, and this is where all of this stuff comes together and we start to work the proofs. We want to prove these arguments as being valid using those basic forms. So number 2, we have F or D then T. Line 2 is not F, D, therefore T. So remember what I taught you in the lecture last time. You want to kind of forget about the conclusion for a moment. Just look at the 3 lines, just like you were doing with that first exercise, and say, all right, so which two could work together to derive a conclusion. And lines 1 and 3 would make a 1 and 2 rather would make a disjunctive syllogism. Again, I'll just do this for a couple of them for you, and then we'll speed up a little bit, but just to help you visualize again. So F is the square, D then T is the circle, F is the square. So it's either square or circle. It's not the square, therefore it has to be the circle, which is if D then T. So here on line 4 we've got if D then T from 1 and 2 through a disjunctive syllogism. Then we're going to go back and look at the lines again, and we can see that 3 and 4 would make a modus ponens. If D then T, D. Right? So if square then circle, square therefore circle, and that's the T. So line 5 is T from 3 and 4 through a modus ponens, and since that's the conclusion we were looking for, we know that one is done. Okay, so that is number 2. Number 4, we have P then G then T. Number 2 is Q then T then E. Number 3 is P4 is Q. Therefore, G then E. Okay. So looking at the lines that are present, we should be able to see very easily that 1 and 3 would make a modus ponens. If P then G then T, P therefore G then T from 1 and 3 modus ponens. And then we can also see that 2 and 4 make a modus ponens. If Q then T then E, Q therefore T then E. Right, so 2 and 4 modus ponens. Now the conclusion that we want to reach is if G then E, and you can see it right here as a hypothetical syllogism. If G then T, if T then E, therefore if G then E, from 5 and 6 through a hypothetical syllogism. Number 6, we have J then K then L. L or J. Not L, therefore not K. Okay. So looking at this one, the first thing that should jump out at us immediately, 2 and 3 would make a disjunctive syllogism. So it's either K or J, it's either L or J. It's not L, so it has to be J. From 2 and 3, disjunctive syllogism. And then 1 and 4 would make a modus ponens. If J then, K then L, J therefore, K then L. 1, 4, modus ponens. Now we want to get to not K, and so you can see that lines 3 and 5 would give you that through modus tollens. If K then L, not L, therefore not K. Right, 3, 5, modus tollens. And again, that's the conclusion you wanted to reach, so that one is proved. Okay. So like I said, this it's pretty easy once you get the hang of it. Hopefully you guys are finding that as we work through these. It's just a matter of getting your eye trained to see these different forms. Let's see, number 8. We have if A then E then not F. Number 2 is H or not F then M. Number 3 is A. Number 4 is not H, therefore E then M. Well, this one's similar to the one we worked back at 4. Right, we're just going to have to whittle it down a little bit. But lines 1 and 3 make a modus ponens. If A then, E then not F. A, therefore, E then not F. Okay, 1, 3, modus ponens. And 2 and 4 make a disjunctive syllogism. It's either H or not F then M. It's not H, so it has to be not F then M. 2-4 disjunctive syllogism. And then 5 and 6 will give us our answer through hypothetical syllogism. If E, then not F. If not F, then M. Therefore, if E, then M. Okay? And again, there's your answer. Number 10, we've got if N, then J, then P. Number 2 is J, then P, then N, then J. Number 3 is N, therefore P. So again, forget about the conclusion, look at the 3 lines, and you can see that 1 and 3 would make a modus ponens. If N, then J, then P. N, therefore J, then P. 1 and 3 modus ponens. Now 2 and 4 would also make a modus ponens. Right, remember again, the antecedent is the square, the consequent is the circle. So if square, then circle, square, therefore circle, which is if N, then J, from 2 and 4 through modus ponens. At number 6, there's actually a couple ways that we could do this, but the one that seems to stand out to me would be to take 4 and 5 and make that a hypothetical syllogism. If N, then J. If J, then P, therefore if N, then P. From 4 and 5 through a hypothetical syllogism. And then 3 and 6 will give us our answer through modus ponens. If N, then P, N, therefore P. Modus ponens. All right, but you could have also, when you got to this point, alternatively, if N, then J, N, therefore J, so 3 and 5 modus ponens. And then line 4, you've got J, then P. Line 6 is J. J, then P. J, therefore P, from 4 and 6 modus ponens. So you could have done the whole thing as modus ponens without hypothetical syllogism. And the point is that sometimes there are more than one way to be able to get these equations figured out. So let's keep that in mind as we go along. Number 12. Not M or B or not T. B or, nope, B then W. Not M. Not W, therefore not T. All right, so this one, if we look at, there's 2 things that we could do immediately. Lines 1 and 3 would make a disjunctive syllogism. 2 and 4 would make a modus tollens. Probably going to need both of those, so it doesn't really matter which ones we start with. But let's start with 1 and 3. So just to visualize this again, not M or B or not T, not M. All right, so the square is the not M, the circle is B or not T. Not M is the square. So it's square or circle. It's not the square, so it has to be the circle, which is B or not T. And so we got that from 1 and 3, disjunctive syllogism. Now, I said that 2 and 4 would also make a modus tollens. If B, then W, not W, therefore not B. 2, 4 modus tollens. And now 5 and 6 make a disjunctive syllogism. It's B or not T. It's not B, so it has to be not T. 5 and 6, disjunctive syllogism. 14, we have L if and only if N, then C. L if and only if N, or, where did it go? P then not E. Number 3 is not E then C. Number 4 is not C, therefore not P. All right. So looking at this one, we can see that, again, there's a couple things we could do. 1 and 4 would make a modus tollens. 3 and 4 would also make a modus tollens. I think we'll start with 1 and 4. So L if and only if N, then C, not C, therefore not L if and only if N. 1 and 4 modus tollens. Then 2 and 5 would make a disjunctive syllogism. It's either L if and only if N, or if P then not E. It's not L if and only if N, so it has to be if P then not E. From 2 and 5 disjunctive syllogism. Alright, so now, remember we saw 3 and 4 was an issue as well, right? Modus tollens. We're going to do that now. So if not E, then C. Not C, therefore not E. 3 and 4 modus tollens. And so now at line 8 we can get our answer from 6 and 7 through a modus tollens. If P, then not E. It's not E, so it has to be not P. And so there's another one proved. (16) We have B then not M, then T then not S. Line 2, B then K. Line 3, K then not M. Line 4, not S then N. And our conclusion, T then N. Alright, so looking at this one's a little bit perhaps trickier in terms of what has to be done here. But I think that the thing I recognize first off the bat is that 2 and 3 would make a hypothetical syllogism. If B, then K. If K, then not M. Therefore, if B, then not M. 2 and 3, hypothetical syllogism. Now once we've got that, we can clearly see that 1 and 5 make modus ponens. Right? So again, the square is the antecedent, the consequent is the circle. So B, then not M, is the square. So if square, then circle, square, therefore circle, which would be if T, then not S, from 1 and